Okay, good morning to everyone. I'm gonna share my screen. You see it? Yeah.
Yes.
Okay, so this is just un adelanto, like so you can see more or less where the class will end, and you keep yourself motivated on through the boring part of the beginning. So you can see on my camera this LED strip, and you can see my screen on Blender. And if I execute this command, LED strip control, and I move my arrow, you can see my lights moving on the LED strip, right?
Very nice.
So more or less, this is the idea. We're going to try to connect the reality with Blender in several ways. We're going to learn a little bit on how to, sorry, I'm fighting Zoom screens that I have too many. There you go. Okay, so the idea is to connect Blender to a smartphone, to an Arduino, and manage data input and output, okay, via the Blender Python interface. So it seems a little bit complicated, but it is not that complicated. And if you grab the idea and the concept, this is very powerful because you can just link whatever you want. You can model a robot inside Blender and have the motors on the outside copying the movements that you do in the inside, or the other way around. You can make a puppet with encoders or with resistors and then copy the movements inside Blender to create animations or whatever you can imagine. So in the exercise we're going to do, one of them involves wireless networks. So we're going to send the data through UDP packages. So I'm going to explain a little bit more about that later. And we are also going to do some exercises through serial port. So there's also some networking involved in the class. So it's Python, Blender, Arduino code, networking, and serial ports all together to create fun stuff, okay? So let's start. Let me go to my, I'm not very good doing classes through a camera, so bear with me. The idea here is that Blender has a full interface written in Python that give you access to everything that's inside Blender, okay? So if you have a new file in Blender, like this, like the ones you have been using normally, you don't see anything like it. But if you go to the last tab, the scripting tab, then you have an interface that's more focused on coding than on 3D. So we're going to work with that interface today. Of course, you can do that in any of the different tabs just by changing the type of screens. And you have the text editor, Python console, and info windows that are focused on coding inside Blender. I'm going to do a brief description of the UI in Blender, and then we go into Python code. This window is for writing code. When you open it, you don't have anything and you cannot type anything. But if you click the new button, then you have a normal text editor inside Blender. This is useful not only for coding Python, because it's useful for, I use it a lot, for example, for keeping notes on my project. So I'm modeling something and I can keep my list of my boom parts on the side and whatever. No? So this is also useful for other things. But today we're going to use it for coding. On the top, you have this header menu. On the top right, you have a run script button. Alt-P is the shortcut for it. We're going to use it a lot when we try to code in Python. This template menu is also very useful because there's a lot of templates of normal tasks that you do in Blender with Python. And at the beginning, that's pretty useful because we don't know how to start. And well, the other menus have the normal functions that a common text editor for programming has. It's not very powerful compared to Beam or to Sublime Text or whatever, but it's usable, sorry. And what else? More or less, that's the case. That's the thing. It has syntax highlighting for Python. You can have several files here. If you click new files, etc., you can keep adding files here. And for now, that's it on the text interface. Then you have, this is pretty useful for learning, the Python console. Okay, you have a real-time Python console to interact with your 3D view or with anything inside Blender. You can, with the control and the middle mouse wheel of the button, you can change the font size, even on both of the windows. Here you have access to your file, your open file in Blender, in a way that you can modify stuff directly from Python. Okay, to be able to use this, we have to learn a little bit of things before, but this is the way to test everything. So you can test any command that you have in your script on real time, and then run your command once you have everything working. And here on the bottom left, you have a window that will pop messages, system messages, let's say the errors, whatever stuff is happening, you're going to see it there. For debugging purposes, it's very important to be able to see errors, because the most common thing is that the script doesn't work and you need to know why it's not working, because you miss some syntax, you miss a tab or whatever, and that information you receive it through here. Okay. So what can we do inside Blender? The theory is that you can access any function that Blender has, any data that's inside Blender, you can access it through Python. To do that, I assume that certain knowledge of Python is already with you. So I'm going to jump some obvious stuff, but if you have questions or you don't follow what I'm saying, please interrupt me. So everything is based on objects, okay? BPI, this first object, is the main object that Python, Blender exposes to us through Python. So sub-objects of those methods, properties from that object will give us access to anything and will let us control anything. So BPI, Blender Python interface, or whatever is the meaning of these three letters, is Y is not interface, so I'm not sure what it is.
Blender Python.
Blender Python, maybe, yeah. I never asked that until I have to teach it. Well, the main object there is the data object, okay? BPI data contains all the data that's in Blender objects, in the 3D objects you have, and in the data blocks, let's say. So if you follow more or less the documentation, you can see that one of the first commands that I put there is this, no? Cube equals BPI data objects cube, right? So let me explain a little bit so we start understanding the structure here. Any object inside Python, you can copy it to another variable, so you can access it through another variable. So here we create a custom variable. I can say whatever name I want, not just cube. It's my cube, for example. No, BPI is the main Blender Python interface. Data is the access to all the data blocks. And objects is a list with all the objects that exist right now inside Blender. Okay, if I create new objects, then that list will contain them. Okay, so what I'm doing here is I'm searching for an object that's called cube. I can access those objects through different things. One of the most simple right now is the name. So as you can see on the top right, this cube is called cube. That's why I put this here, right? So if the name is different, then I have to use that name here. So if I do this, nothing happens, but now inside my cube, there is a shortcut, let's say, to this object, okay? Before that, every time I want to access and modify or ask something about this object, I have to type all of this. So it's a shortcut that allows us to access objects in a simpler way. Talking about shortcuts, if you see the first message on the screen of the console, Python console, you see these convenience variables, okay? C equals BPI context, and D uppercase is linked to BPI data. So in fact, what I just wrote is the same that if I wrote D dot objects cube, right? It's the same because D is a shortcut for BPA data, okay? And C is a shortcut for BPA context. That's some convenience shortcuts that Blender puts there for us, just for you to use. And also Blender imports math utils and some everything inside math, so you can access it directly. Of course, you can do that by yourself. If you want to use a serial port, like in any Python console, you just do import serial, right? And then you have access to a serial port library. Any Python library that you want to use, you can access it through this console. It's the same like a Python system console. Okay, so now if I ask for my cube location, I can ask for example, X location, and I receive a value. Okay, that's one of the properties of the cube. It makes sense, no? A cube has a location, and a location has an X coordinate. So I can ask for it, but I can also say that I want to change it. So as you can see, my cube has moved once I execute this command, right? Because I assign to that location a value of 1. If I want to take my cube back, I just assign a 0, and the cube goes back to 0, right? So more or less, it's a very simple logic. You have properties of an object, and you can assign values, get those values, which whatever Python tool you like. One parenthesis here. As you can see here, there's a lot of green words. That's autocomplete. Blender offers autocomplete possibilities inside the console. That's very useful because normally we don't know the names of the properties or the methods we're searching. So if I do my cube dot and I click tab, I see all the properties and methods that cube has, right? There's a lot. But I can start writing an LO and then all the properties that include LO, location or something like that, no? It's like a fuzzy finder, it's not directly. So location dot and then another tab, and he offers me all the ways to access that location data. It's a lot also, okay? For example, I can access the full location
that is too many axes.
Sorry? Too many
axes, Z, Y, Z, Y.
Yeah.
Y.
Different ways to access at the end the same data. I cannot explain you all of them. I will link you to the proper documentation so you can check any of them. The most common way to access location is XYZ in 3 coordinates, but there's a lot of different ways to access it and a lot of information that I don't know how to explain right now. So don't ask me details like what is this? ZZZZZ is some freaky, strange way to access just 4 Z's, or is a way to access more detailed information about Z axis? I'm not sure. We should check that on the API.
It's when you fall asleep.
Exactly. It's yesterday night when I start researching about this one, and then I fall asleep and I don't get to this one. So no, but the logic and simple way is location is a vector with 3 variables. So you can just read it, or you can access it and modify it with a vector saying 2, 3, 1.5, for example. So I'm changing the 3 axes in one instruction, okay? And you can see my cube moved. And if you see the properties here on the 3D window, you can see exactly the same values that I just typed here, right? And if I do a change here, and I ask for location again, I have that value here, right? So this is the basic way of accessing Blender's data through Python. A couple of tips that will help you is, I don't know if you know this command in Python. Dir command will give you information about any object. So if I say dir my cube, I will see all the properties and methods that that cube has. It's the same that typing a tab, but presented in a list here. And that dir command works in any Python environment, not only inside Blender. And the tab, the autocomplete that Python Blender has is not accessible in any place. What else I can show you about tricks? Yeah, this is important. It is on the document, but I'm going to show it here. If you go to, I don't know why my window is not, so Zoom messes with my window in some way, so I cannot access these menus. So I'm going to do it through here. You should just open the preferences window. You can do it through the menu if you have a normal, not Zoom Blender. And here in the interfaces, there is this option, Python tooltips. Okay, this allows Blender to show us a lot more information when you stop on top of a button. You see not only the normal tooltip, but underneath in gray, you see Python and what's the method or the property that that button is related to inside Python. Okay, that's pretty useful because if you want to move this cube, then you go to, for example, object transform move, you stay there and you see bpi.ops.transform.translate is the method that moves the object, right, inside Python. So it's a pretty easy way to find out how to do stuff that you normally do in Blender interface, but in Python. And one more thing is that if you type, when you are on top of the command, if you do Control-C, and then you do Control-B on the Python console, you have that command, okay? So that's pretty useful to start working on it, because you don't know how to move something, then you go check the command, copy the Python code, go back and paste it, okay? So turn on these Python tooltips if you intend to do the work we are doing in this class. It will help you a lot. What else as a general stuff? Okay, Python API documentation. There's a link on the document in the documentation. And also if you go here, sorry, but my Zoom doesn't give me access to it. Maybe if I do it like this, you still see my window? Yeah.
Yeah.
Okay. So help, there's also here Python API reference. Okay. So you can access it through here. It will open a web page in your browser. It's not inside Blender, the access to this, but it's important because there's a lot of parameters. For example, I know that this will move the cube, but how should I type that values? I don't know. So the other option is go inside the parentheses and hit tab, and Blender will show us all the options that we can type inside that that function. For example, here value equals, and then I can use 3 coordinates 2, 2, 2, and that will move my cube in a vector of 2, 2, 2 with that direction to the top right? But I can also change my orientation matrix. I can also change whatever you see here in these options. Okay. The explanation of all those parameters is in the Python API. So if you want to go deep into some strange function, you want to control a modifier that you are adding to an object to do some fancy stuff, you should find that on the API. Okay, we're not going to go that deep into this class because this is an introductory class, but you have access to all the details, and you have access, for example, to save any modification you do as a keyframe on time, so you can build animations, stuff like that. Okay. Now, that's a big picture on the tools you have inside Blender to write code or to access Blender through a Python interface. It's important to keep in mind that this is not just the geeky way of accessing Blender instead of clicking buttons. The thing is that once you can do this properly, you can write code that does this automatically. So if you want to distribute 1,000 cubes with a random pattern, you can search for a fancy way to do that with the buttons, or you can just write a random function with Python that creates cubes and puts them inside the 3D space in a couple of lines of code, right? So it is very powerful. I know that at the beginning it doesn't show, but it is very powerful when you want to do more, less, or modeling is not, the modeling you want to do is not oriented to just build one geometry, specific geometry. Okay. I'm sorry, my English is not so good this time in the morning. The API. Documentation of the API is on the page I already said. I'm going to do a brief explanation on the main parts of the API. As you can see, the most accessed part of the Blender interface is the data object. The data objects contain access to all the data blocks. It is organized in different ways. You can access the same data through different ways. For example, this object, you can access it through the list of objects with names, as we did on the beginning, but you can also access it through the active object context, or you can access it through different ways, let's say. There are different interfaces to the same data. So you have to use the one that more fits your needs. No? For example, in this instruction that I executed, you don't see in any place the name cube, or you don't see any reference to this cube, in fact. But the one that moved was that cube and not another object. Why? Because I had it selected. So when you execute an operation, I'm going to explain this a little bit later, it will apply to the selected object, right? And you can access selected objects as a list. You can access active object, etc. So data access is, remember, D, or is a struct with blend data. You can access it through bpi.data. It's the same. And inside that, if you do a dir D, you will see what do you have, right? Paths, fonts, grease pencil, objects, meshes, metaballs, movie clips, whatever data is inside your Blender file. A lot of those containers or objects are empty because I don't have anything inside them still. I can create objects through Python interface, or I can just add them via normal interface and then modify them through Python interface, okay? So you can do both works. You don't need to do only Python or only buttons. You can build your own tools in Python and then start modeling here and then have a tool to replicate this with a specific pattern with a couple of variables, for example, no? Or you can do a Python script to change the dimensions of your parametric mesh very easily in a script in a way that you can just click it. And the good thing is once you write a script, you can access it through a shortcut, let's say. You can add it as a kind of a button. More advanced programming will end up in building an add-on for Blender. It's not so complex. There's a couple of tutorials on how to build add-ons, but first you need to start to learn how to use Python, then how to write scripts that you can call, and then you can convert those scripts into working add-ons that will show up in a normal, for example, like this 3D print add-on, okay? So since you have access to all Python, all Blender data through Python, you can write tools that are very powerful and later share them with the community, obviously. Then we have BPI, coming back to Python interface, BPI context.
Wait a bit, I see that Daniel is asking something that I also would like to know. That is, if there is a way to record the actions you do in Blender. So for example, I do something, I want to record it and save it again so I can do it then repeatedly.
I don't know. I'm sorry, I don't know. We have to research it. I never done that in Blender. It's possible that there's a way. I can imagine you can write a script to do that because all the actions are registered in the Python interface, but I don't know. That's my answer. We have to.
But you can access the register of Python, so you can check what are the actions that you have done.
Yeah, as far as I remember, Python interface has changed a lot in the last version. So I'm very stupid in remembering all the things because I'm used to the old things. But as far as I understand, I think you can access it through BPI context.
But the bottom left of your screen is where it says what you do. Like if you move the cube, it's
but
so
the
you
idea
can just
will be
log
to
this.
Yeah, sorry, finish.
No, sorry, I was just saying if you just log what the console says, then it's a script. No?
Of course, and I think you can access that through a Python list via the BPI context, but I'm not sure where it is. We have to search for it. But in that way, you should have a way to save that as a set of instructions and replicate them later. But I haven't done that and I don't know how to do it. I'm sure it is possible. And maybe there's already a tool to do that, writing down. So it's just a matter of doing a little bit of research. But that's a good question. When you come from a Photoshop world or stuff like that, where you record your actions, that's a normal way of doing, no? And recording macros in other software. So I'm sure there's something like it, but sorry, I cannot answer you how to do it. So that gives me entrance to what I was saying, the BPI context, okay? BPI context will give you data around whatever surrounds your objects, your data blocks, let's say, okay? So for example, BPI context object will tell me the object that I have now. For example, this is cube 001, and if I select the other one, then it returns me the other cube, right? So this is another way to access the same object, the different objects through not the data block, but through the context block. And as you can see, it will return me the data of that object that's inside another object, but it's like a shortcut, like a link, let's say. Okay, so context will allow us to access different things. For example, selected object will show me only that one, but if I select both with Shift, then I see both. I receive a list with both objects, right? And you can access a lot of different things inside BPI context. Clicking tab here will show you a lot of different parts of Blender context, okay? Visible objects. If you hide some objects, you can access only the visible ones or the hidden ones, or so you can modify a lot of the properties accessing those objects or those data through the context. Then we have BPI ops, okay? BPI ops is operations, normally called tools. So you can move an object, you can transform, scale, whatever, an object, whatever property in Blender through an operation, okay? There's a lot of operators, let's say, already built into Blender. Those are the same that you have here in the menu. If you see here, BPI, ops, transform, mirror, etc., etc. If I copy that and paste it here, you will see it refers to BPI ops, okay? So anything that you apply to an object or to a video or to whatever data block you want, you can access it through an operator. And the good thing is that you can write your own operators, obviously, in Python, and then register them inside Blender so you can access them as normal tools. That's what we're going to do today with a couple of lines of code. Okay, so BPI data, BPI context, and BPI ops are the three objects that we are normally going to use as beginners in this Blender Python interface. Okay, until here, more questions? No? Okay. How many people is here, more or less?
12.
12, okay. I'm going to try to maintain a flow of the class like if we were in the classroom in terms of doing an exercise. I'm going to do it as a demo. It's not intended for you to replicate it on the same time, but it will be nice if you later can try to do what I'm going to show you here. I think you will have access to the recordings of this class later, so you can check the details. And in the documentation, there's a lot of reference for it. So if you don't understand something that I've done, please stop me and ask me questions, but keep in mind that it's not intended for you to do that on real time with me, okay? Because some tasks are a little bit complex and we can take too much time if everyone tries to do it at the same time. And 12, I think, is a little bit too much. If we were 5, maybe we can try it. But
Victor,
so,
but I'm
yeah.
Now it makes me think that it has something interesting what you say.
Yeah.
That it's happening, but this idea that you do a class and then maybe we can structure a little bit how the people try to implement by their own what you explained in the class and visualize it somehow, all the effort that everybody did at the class. It's something that maybe also for you it's interesting. What I'm saying is like right now we are doing a lot of classes in video classes, let's say, but then especially the instructors, let's say, or the people that do the class, they don't know how the people is applying that knowledge. So it will be nice also to see how the students like they are applying. So maybe we can, I don't know, we can ask people to send a link or document what they try, things like this.
Yeah,
it's just
it would be nice to see
tracking that this thing, no?
Yeah.
Okay, let me think about this. I will try to.
Yeah, it will be nice to have like a repository of documentation on how
maybe,
they did it, on if it worked, which ones are the problems, etc. Yeah.
I mean, now it happens in the documentations, but more like an isolated, let's say. But if it's something that could be like structured, it will be nice.
It will be nice, yeah. And of course, I don't have the proper infrastructure because I'm not used to this, but it will be nice to have a different camera pointing to what I'm doing with my hands, and also the screen in another window so you can see. I'm sorry, it's not going to be so nice, but I'm not going to work on that infrastructure because I don't want to live inside my home. So I will keep doing classes on the classroom as soon as they let me.
In this case, just if you need to show something on camera, just say, look what I have here on camera. So we have the time to switch to your camera and see what you are trying to show us, and it's fine.
Okay, okay. So first of all, we're going to try one first exercise that's an input from the external world into Blender. Okay, you can follow in the documentation I did all the steps I'm going to do. It involves installing an application in a smartphone. You know me and you know that I'm not a smartphone fan, but it's a tool that all of you have at home. So it's a good excuse to do networking and to send data to Blender from a sensor that you already have. Normally, I will prefer to do this with an accelerometer and an ESP32, sending the data through the Wi-Fi. But right now, using a smartphone is a convenience solution for this situation. So I found a free, if you look at my camera, not at the screen. In fact, let me unshare my screen so you see my camera normally. Okay, here. I found an application that's pretty simple and it's free for Android. In the documentation, there's a link so you can do this. I'm sure there's an equivalent for iOS. Sorry, I didn't take the time to do it, but it's on your side to research a little bit. I'm sure it's not difficult to find. What we want is an application that can push data from your phone sensors through the network via preferably UDP packages, not TCP. TCP can work also, but UDP normally is faster for this kind of tasks. Okay? Everyone knows the difference between UDP and TCP?
That's all now.
Sorry? No.
Nah.
Oh, we don't.
So I'm going to explain a little bit around this subject. I can use this as an excuse to talk a little bit about
Victor.
networks. Yeah, tell me.
Sorry. This week they will do networking.
Networking. Okay, so take this as a small introduction on Victor's style to networking. Okay, so we send packages through the network. Packages, that means I want to send a number of my sensor, and I pack that number inside another wrapping data that allows me to know from where that data comes from, where that data goes to, etc., etc. So I package that and send it through a protocol, through the network, but based on a protocol, let's say. A protocol is a way to state some rules, to be able to communicate between two parts. Okay, the language we are using right now is kind of a protocol because it has some delimited words that you understand if I say them, and there's some rules on how to organize those words in a way that I can transmit some information and you can receive it properly. So think of this as the same idea. So TCP/IP is a transfer control protocol, internet protocol, is the most normal protocol we use to communicate computers. There's a lot of different protocols for networks, but that's a pretty common one that we use every day when we browse the web, when we access any web server, etc. So it is based on this idea of packages. Information can be short or can be long, but we want to standardize it with a maximum size in package, so we can fragment that information and send it through different channels and different speeds very in a robust way. And we can check if the package number 3 of the web page arrived or not, and we can re-ask that package if we have an error on the network, etc. Because as you know, any electronic system or any kind of system has errors, always. So you don't have to try to avoid errors, you just have to learn how to deal with them and correct them, right? So this is the idea of dividing info and packages. So making the long story a little bit shorter, we have mostly 2 types of packages in this protocol, TCP and UDP. I'm not going to go deeper into explaining them, but TCP demands an answer from the other side that tells you, hey, okay, I received that info. And UDP doesn't. UDP just pushes data as crazy. And if the other guy receives it or not is his problem, right? So you are not waiting for an answer to send the next package. That means that the phone can read the sensors as fast as he can and send info as crazy. And your computer would receive that info. And if the computer loses some packages, it doesn't matter. He doesn't stop or waste resources on checking if all the packages were received, okay? So there are some informations that you send via TCP because you know it's mandatory to be received. If you want to say a word, it's mandatory that you receive all the letters, right? Because if you miss one letter, then the word doesn't make sense. But if you are just sending the same number several times and just changing, for example, a value in a sensor, and you don't receive one reading, it's not important. The rest of the readings are valid still, even if you don't receive one of them, right? And it's a lot faster because you don't have to do all the interchange to see if you received what I said, etc. So, for example, what we are doing in this class today is kind of an UDP stuff. I'm just talking like crazy to a camera, and you receive the info or not, I don't care. I don't see if you really received what I said. No, maybe in your gestures, no, with some smiles right now, then I'm seeing that you are hearing what I'm saying. But if there is no gesture on your side, I don't know what happened, and I keep talking. If I waste time on seeing if you received that information, then it's TCP, right? And I need more resources to see, oh, okay, this guy, yeah, he's smiling. Oh yeah, he's doing this. He received what I said, no? That's TCP, and UDP is just keep talking. So this guy is just gonna keep talking, okay? So we install an application that reads the sensor. Inside this kind of devices, there's a lot of sensors, more than the ones that I like, that can read anything. So for this exercise, in this app that I found, there's a couple of tabs only. The first tab is to set up the communication and the network. I'm not gonna show it while I type it. It's on the documentation, all the settings that you need to modify. And the second tab, let me choose the sensors I want to send, okay? I'm gonna use a sensor that they call orientation, okay? Orientation is based on accelerometer data, but it won't give me the raw data. It will give me an angle. So it will give me a value between 0 and 360 degrees that tell me the angle of my phone, okay? That's the simplest way to know the position and to translate that position to an object in Blender. So the exercise will consist in gathering the angle of my phone and rotating an object inside Blender based on that angle, okay? So the phone is gonna check his accelerometer, is gonna convert that data to an angle, it's gonna send it through UDP to a network, and we're gonna set up Blender to receive that data via Python and apply that to a property of an object, okay? The big picture is more or less understood, I hope. So let's set up the phone. I select the proper sensor. Then I go to the preference tab that is networking tabs. The first one is the target IP address. Everyone knows what an IP address? Yeah.
Yes.
I shouldn't go into that, okay?
Victor, did you buy a smartphone for the class?
No, I have a smartphone on my drawer.
It's his daughter's.
I need to do fancy stuff. So I take it out, and when I want to experiment how to put Linux in a smartphone, I have to. I love hardware. I don't love this kind of software, but I love hardware. So playing with it is fun. But I have under a drawer with a key, so no one took it to play. Okay, so I was trying yesterday to do the class with my normal phone, but I didn't find an excuse to send data from here to there, so I have to took the big stuff. Okay, so the IP, target IP, is to which IP I'm going to direct those packages. So I have to check the IP of my computer or whatever device that has Blender inside and type it here, okay? In numeric or in a name if my network is set up in a way that I can access names. Normally, for normal people, you can find your IP in your computer, depending on which system you're using, on the network properties or whatever. So I know that my IP address ends up in 12. I set up that, and I have to set up a port, okay? Everyone knows what's a port in computers terms? Yeah.
Yeah.
Can anyone explain it to me?
No.
Someone.
It's like the door number. It's like a door number to the computer.
Okay, perfect. So we want to specify a door number that no one else is using, so we don't mess with other stuff and no one messes with our sensor data, right? So here, as a default, it comes 5555, okay? This is a normal practice to use strange port numbers, really high numbers, so no one else is using them. For example, SSH is port 22, HTTP is port 80, etc. So don't use any normal port. Try to use a safer port. 555 seems to be a usable one.
666.
666 also. Then there's in this app, not every app that you will find for this will have the same settings. You have to realize what you're doing. But here is like a frequency of sending data in just 4 options: slow, medium, fast, and fastest. Okay. Some of them will have an interval in milliseconds or in seconds or a menu similar to this, but start slow and go fast little by little, okay? Networks, when you go too fast, tend to choke and to jam. So start slowly and then go your way up. I tested this yesterday, so going in fast works pretty acceptable, and fastest, it doesn't work okay, because the phone pushes data too fast for my network at least, okay? So it depends on your setup. It depends on a lot of things. I found yesterday a tool that was pretty nice, but it didn't work nice with Blender, but I just mentioned this because for other exercises could be a good tool called VFox or something like that. I will post the link later. That will allow you to access all your sensor data from your phone from any web page, from any web browser. So it creates like kind of a server on your phone, and you can access it through an API command, normal, and you can access it through Python, through JavaScript, through whatever. So it's a nice tool for the kind of exercises that you will do on Fab Academy, accessing any sensor on your phone through an API. And I'm gonna tick run in background, okay? So now I have a button to switch the stream on or off. This device has the option to do UDP stream, SD card. I don't want to save them on SD card, but it's another option. You can program your Python to later read the SD card and use that data, not on real time, but for example, to save like a puppetry, like capture animation, let's say, you can save it on SD card and later use those movements to animate something. You can put your phone, I see yesterday a couple of demos from a guy that was using his phone accelerator to modify MIDI sounds from his computer. So he puts the phone, for example, in his foot, and he creates a wah-wah pedal for guitar just by moving the phone. No? He's modifying the sound with the angle of the phone. He puts the phone on his head with the tape and playing the drums like a different, more or high pitch, low pitch sounds, etc. No? So it's a cool tool to do that, to learn to do that. Okay, coming back, UDP stream, switch on. So I should be able to read that data. I don't know what's happening. As you can see, my phone just have a so it's sending data, but we don't see that data in anywhere, right? So now let's go to the other side. Let's receive that data. And once we receive that data, let's integrate that data inside Blender, okay? I'm gonna share my screen. I hope, so you can see what I'm doing. You see my Blender screen, right? Okay. So Python console, I'm going to open a file that I already prepared for this, so we don't take too much time, but I'm going to try to guide you step by step so you understand the full idea. I think, the name of the file, FeeFox, is the name of the app that I told you about sharing data from your phone as a web server. I'm going to type it so I don't forget on the chat. It's feefox.org, I think. feefox.org, okay? Now, coming back to this. Here I have my monkey, I have my code, and I can rotate that monkey with my phone if I run it. Let me see if it's still working. Let's run the code. No, I see an error. Python script failed. So do you see that extra window? No. No, let me, the thing is,
remember that you can share your screen or you can share only a specific window.
Okay, I will reorganize things so you can see all my screen, I think. Wait for me a second so you can see everything. Oops. Sorry, eh?
Don't worry.
Okay, share screen. I think I'm gonna, the thing is my screen is 2 monitors, so it's a little bit of a mess. Desktop 2, I can share only one desktop. You see 2 things, a terminal here and a Blender here?
Yeah.
Yes.
Yeah, perfect. Okay, so I'm gonna organize it like this. And on the bottom, we are gonna see the things that Python is complaining about. Okay, the way to do this is in Windows, I think it happens as a default. Once you open Blender, you have a small terminal window where you see messages. In Linux, and I can imagine that in Mac also, you just open a terminal and run Blender. So that way you see all the output from Blender in the terminal. Okay, so I'm gonna open the same file, feefox.blend. And now if I run my script, I can see the errors here, okay? And the error is calling operator, oops, will not. I don't know what's that error. Okay, let's go step by steps to see if we can solve it. So here I have my console, my monkey, and my code. I'm gonna go a little bit through the code as a starting point, and then we're gonna try to solve what's that problem. I don't follow that problem, okay. So it seems like a lot of code, but I didn't wrote most of that code, okay? This code is to create an operator. Remember that I explained before what an operator was? Any tool that you can apply to an object, it's an operator. So we're going to create an operator like the one that helps you rotate your monkey. You can go here and say transform, rotate, and say I want to rotate it on the x-axis. So this is an operator that we are applying to the monkey. So we're going to write an operator that will rotate the monkey, but based on the data that comes from the phone and not the data that comes from the mouse, okay? So basically it's similar, but the data source is different. So the good thing is Blender has a lot of templates, okay? Like this. So if I start a new file or another file here, text, and I go template Python operator timer, I'm going to explain why, it will put all that code there, and I can just add or remove stuff to create my own operator, okay? So that's what I did. I didn't wrote all the stuff. And I think mine is this one. Yeah. So I added a couple of lines. Import socket. Import in Python is a way to load libraries. It's the same that in Arduino you write include in C, right? So I'm importing a library called socket. This library will allow me to create a socket. That means a network connection with a specific IP address in a specific port, okay? Remember the app on the phone, we did the same. We create a stream of data via UDP in a port and an address and directed through an address, okay? So on the network side, we're going to use that. I can write this here, import socket, to see if it works. If Blender doesn't complain, it means it has access to that library and it's working, okay? When you're trying to import something that doesn't exist or is not installed, you will see this. Hey, 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 I don't find that, okay? So now I have socket library loaded. All of this code is already in the template I load. I just change here the label. So the command will be rotate Suzanne with your phone, right? So when you call or search for that command, you will find it with the proper title to do whatever you like. The default template comes with a model timer operator, okay? So let me go back a little bit because I jumped a couple of things. In the templates, there's a lot of different operators, okay? Those operators execute different commands, and the timer operator is an operator that will execute commands based on a timer. That means it will keep executing the commands on an interval that you define, okay? It doesn't depend on you doing an action or an event on the mouse or whatever. It always does it based on a timer. Because we don't know what's happening with the phone, we just check every now and then if we have new data and we use that data. Of course, there are different ways of doing this. The proper way of doing this, but a little bit more complex, is to always monitor the network and act when you receive a package, not just to do it based on a timer. But it's a lot simpler. The logic is a lot simpler when you do it based on a timer. So that's why I did it this way. Okay, so I modified the label. That I think is not complex to understand. And I add all these lines here. As you can see, this is a class declaration in Python. All of this is a class until here. And then we have a couple of functions, register, unregister, and then we have the main function, let's say, what's going to happen when we run the script. I hope all of you have an idea of Python and object-oriented programming. So here we create an object, similar as the objects that Blender offers to us, like BPI data. And our object is a model time operator object. Here we call a register class, that means that we're asking Blender to register our operator, to include it in his interface, okay? So we're asking him to add this model time operator that we created, right? And here we ask Blender to unregister it. So when we run our code, we register this as an extra Blender tool. And when we finish running our code, we remove that from Blender, so it doesn't remain in the Blender interface. And the main code, what it does is register. So it calls this instruction, it registers our code in Blender and execute it, okay? Until here, questions? It's clear the main structure is a class, register that class, unregister that class, depending on the beginning or the end of our script. And inside the class, we're going to do all our stuff. I'm going to explain it right now. But we have to create an object to register with our methods or functions in Blender, okay? And we use this kind of templates so to make our life easier. We can write, obviously, all this from zero, but it's a little bit more complex. So when we declare the class, when we create our object, we have to do some stuff. And in that stuff, we define things like the title of our operator. ID name is something that's required by Blender. We define a timer, a variable that keeps tracking of time, because remember, we're going to execute this function based on a timer now and on an interval. So we use this variable to count time. This is already there because we load a template for a timer operator. So I didn't put this here. I put all of this here and some other stuff down there. My first variable is host. Host is the IP of my computer, okay? Because my computer will act as a server and my phone will act as a client that's sending data to that server. So on my phone side, I wrote the same IP address, you can see it, I think, in my camera, that I have here, the 012, okay? That's the IP of my computer. And the port, that's obviously the same one that I set up in my phone. Then I create a socket, okay? Remember, I load this socket. So let's try to do these instructions on the console to see what happens. So I copy this to the console. Okay, I have already a variable called host, a variable called port. If I ask to the console who's the host, he will tell me the host is this IP. Then I will create a socket. All the names, strange names that you see on side parentheses, don't pay them too much attention, just copy them. Or if you want to understand them, you have to go to the documentation of the socket library to understand what they do. Those are things related to the socket, the network socket. Then after creating that socket, I store that socket inside this variable called S. Okay, so inside X, you can see there's a socket with all these settings. Okay, it's still with an address 000 because I haven't set up the address yet. Now I do this couple of instructions. I'm not going to explain them mainly because I don't understand them. So these kind of things are based on examples. Now this instruction is important. Bind my socket, that means connect my socket with another device on this host. Remember, host is this address on this port. So that instruction is the one that's creating the connection between my phone and my computer. And in theory right now, because he didn't complain, I already have a connection. I'm just not asking for data, but the data is there and the connection, the network connection is established. Okay? So those lines set up all the network. In theory, it's working okay. And now I have this function that comes as a default with the template. and this function is going to be executed when this other execute function calls it. Okay, so it's executed on this interval. All this code is already there in the example of Blender template. So the only thing you need to understand and keep in mind is everything that you put inside model is going to be executed based on this interval. That means 0.1 seconds. So these instructions are going to be called every 0.1 seconds when you run this code. Okay? So these are just events to be able to get out of the function, because once I run my code, it's going to keep doing it until something happens. So if event right mouse, that means my mouse button, or ESC key, then get out of here, cancel this. So that's the way to stop my script, with the right mouse or with the ESC key. It's important to remember, because you can create a loop where you cannot get out of Blender if you don't do it properly. Okay, so keep that in mind, because sometimes you write a lot of code, then run it, and then you hang everything and you lose your code. Okay, so keep in mind that it's important to save your code before running it, and always keep a way out of it. Maybe just don't do it permanently, break it after some seconds, or have a key or a mouse button to cancel. Now, if event type timer, I think that's self-explanatory, if the timer is being called, and that's what I wrote to do the thing. This try and except is because if some error happens on the network, I don't want Python to break and interrupt the execution. So if this doesn't work, he just jump and do nothing and tries again later. Okay, if you don't add this, when the network has an error, your script will stop. Okay, and we don't want that. We want to keep going until we have proper data. So first of all, I get the data, message address equals socket. As you can see, I added this self before the S. The S is the socket I create. That's because this is a class, and that's a property of the class. So in my console, I just need to remove that self, because S is just an object independent of anyone. In the case of a class, you need to call his properties as self properties. So in theory, what we're doing here is getting data received from the address we already set up, 1 kbyte, okay, 8,000 bytes of data. And that data, because of how socket works, is organized in the message and the address where it comes from. So if we execute this and everything works, and I ask Python to show me the message, I see the data. Okay, if I do it again, I should see I should see a different data. Message again, and that data should be different than the other one. In fact, I received more, because there are some sensors that doesn't come in every message. So I'm going to ask for it again. So message address, oops, indentation. Sorry, I'm a little bit slow here. If I check the address, I see it comes from the IP of my phone and another port, right? Because the port that outputs can be different of the port that inputs. And if I check the message, I see the data, right? As you can see, the app that I downloaded sends a lot of data, because you cannot disable all the different accelerator values and stuff from the IMU. So the only data that is important for me is these last three values, X, Y, and Z. I think the order is different, X, Y, and Z, yeah. The last three, okay? As you can see here, it is, if I move my phone, I should receive, I just grab my phone and put it vertical. So I should see a different value. And no, it didn't change still, because since I'm not gathering the data fast enough, it is some data accumulated on the network. So I should have to do this several times. Don't worry, we are going to do that on real time on the script. So the data is, the buffer, let's say, is empty, and we see the changes on real time. So I hope that part is clear. With that line, we get the data from the phone as magic. No, we just ask from the S object to receive data, and we get the data. Now that data comes in a list separated with commas, and we need to split that data. Okay, I know that it comes organized in the last three values, let's say, comes the orientation that I asked from the phone. So if I execute this line, what I'm doing is, I'm going to explain it little by little, grabbing the message, splitting the message by commas, okay? As you can see, commas are separating the values. I'm getting the last second, the second value from the right, -2. This is -1, this is -2. And multiplying this by this magic number. This magic number is a way to convert degrees to radians, okay? Blender uses radians in the input to change the rotation Euler. So I need to convert the degrees that my phone is delivering into radians. And then I store that as a float value in my X variable, okay? So I do that for X, Y, and Z. I print those values so I can see them here on the console. And later, I just assign that value to the object I have selected. And context is not defined because I need to bpi.context, right? So I assign that value to Suzanne. If I rotate Suzanne on the X and I assign it again, you can see it rotates based on that value, okay? So now let's try again to run it. I can just click here and still pops out an error. Let's
it's
check
because the last line, it needs to be, if you go on the last line, it says bpy.ops.wm.modal and w8wm.modal is at the top of the file. It should be the BLID name.
It should be this.
BLID. If you open the template of a modal timer, you can see the last line.
Let's check.
The first line, BLID name is WM modal timer.
Model timer, BPIOps, WM.
BLID name. And if you check the BLID name, it's the same.
Okay. So
and you
I
have a different name.
This object model operator. Okay. Yeah, the thing is, I was playing yesterday with model operators and timer operators, so it seems like I messed up. So in theory, thank you very much, Ben.
I think you want the WM.
The other way around?
You want
object model operator. Okay, with the
WM. I'm guessing. I'm just.
Let's try. The normal timer comes exactly like that. So, yeah, I don't know when I changed this. Maybe because I tested this last night and it was working, but I think I don't see now the problem. Oh, it's running, but I'm not receiving any data. Yeah, there you go. Okay, you can see the console, the data is popping. And if I move my phone, you should see my monkey is jumping a little bit, but you can see my monkey moving, right? So there's a lot of jumps because in my code, I didn't clean any errors on the network. So if I receive a strange value, I still push it to the monkey. And it's normal that I receive errors on the phone side or on the network side, okay? And it's a little bit slow. I don't know what's happening right now. I have to debug it a little bit. Yesterday, it was a lot faster. Maybe my daughter is watching a YouTube video in my network.
So, because of the Zoom.
Maybe you are using Zoom, so the network is...
yeah, you're right. Zoom is the one to blame, I'm sure. Okay, so...
Always blaming your daughters.
Yeah, I always do that when I don't know what's happening. So I'm a bad father. But in this case, for example, what you can do is make a hotspot on your phone and connect, or on your computer, and do a direct connection so you don't have any network interference. Okay, so you can see down here on the console, because I have a print message here, that X, Y, and Z is being printed on real time. And you can see that your phone is controlling your object. Okay, this is a simple example, I know, and it's not the most beautiful, but I think it will show all the caveats and all the ins and outs to do stuff like this. Now, if I click ESC, in theory, it should stop. It does. Okay. A couple of advices on this. If you stop the data flow from your phone side, Blender can hang a little bit because you have something that's trying to gather data. So it is good to write your code in a way that that doesn't happen, okay? The try and except are a good method of doing this. If you don't use this and the socket is not being able to receive data, it can hang for some timeout. And if you're calling this over and over and the timeout is bigger than the interval of your timer, you can get stuck, okay? So try to start slowly, and when everything works, you crank up the speed, okay? So this is a way to read any kind of device from the outside via network with UDP packages and a socket. To go deeper into this, you can research a little bit about the socket interface and the phone data. There are different apps that can push different data. Okay? Until here, any question? I took a lot of time on this example, and my calculations were that this was going to be faster. So I'm going to jump to the third exercise, not doing the second one, because if not, we're going to stay here until 4 o'clock. So if no one has questions about this, you can try to replicate it. I think you have all the tools to do it. It's not complex. And my code and my example is on the web page. It is posted. Maybe the error we just fixed is not fixed there. I don't remember at which time of the night I copied the code to the web page. So if you found an error like this, remember that we fixed it having the same ID name here than the one that we're calling here. Okay? Okay, so let's go for the second one. The second one doesn't involve a phone. I'm going to jump to the third one, sorry. This third one involves an Arduino Uno. I hope you can see it on your screen. I'm showing it on the camera. It's connected via USB cable to my computer. And I have connected a LED strip. Okay, you can do this with any kind of output. This was the thing I found on my closet, so I did the exercise with this, but you can do it with any kind of LEDs, use motors, use whatever output you have available at home. And in the documentation, the second exercise that I'm not going to do it right now, uses the built-in LED on Arduino to do an example. So if you don't have anything to play with, you can at least control the LED on the Arduino through Blender, so you understand the steps, okay? So I'm gonna load the LED strip example I did yesterday. I'm gonna explain it briefly. Here I just model a LED strip with 20 LEDs. That's the size of my real LED strip here on the camera. I have 20 small spheres based on an array. I have a box underneath, and in fact that's not needed. It's just to show you that you can create an interface with it in a 3D way. And I create an arrow. That's the arrow I'm going to use to really control my LEDs, okay? So this object is movable just in an axis, in X, and just with the limit that limits his movement from the first to the last LED. To do that, here on Blender, you can access in the right, this constraint menu, and you can add different kinds of constraints. Okay, so I constrained the movement of my object to not move in Y axis. That's why I put 0 and 0 as minimum and maximum Y. So if I try to move my object in Y, it won't move because it is stuck in 0, 0. If I turn this off and I move my object, and I move my object, now I can move it in X and Y. And X has a limit of this. I cannot move it outside my LED strip, neither on the other side. Okay? Still, if you see it on 3D, I cannot move my object up and down because Z is still limited. Okay? So you can create a constraint so your object only moves wherever you want it to move to control your specific arrangement. Okay? So I want a slider from 0 to 20 to see which one of the LEDs I want to turn on. Okay? That's why I have -50 to 50. I can move these so it goes from 0 to 100 or whatever. You can set it up as you like. Now, if I move to my Arduino desktop, you see it or not? Are you seeing Blender or Arduino right now?
Arduino.
Arduino, perfect. So let me close this and this. Okay, we have two parts of code right now because we are going to interact. In the case of the phone, we use code that someone else built and we download an app. But in the case of the Arduino, we are going to write the code on the Arduino and on Blender, okay? This is the code that runs on the Arduino, and I'm going to explain it briefly. I don't know if you know a little bit about LED strips, but I'm not going to go deeply into that, but there's a library, a very simple library that Adafruit does to control NeoPixel strips. So I include that library. I declare a strip called pixels with 20 pixels in the pin number 6. Okay, this extra stuff is explained on the documentation of the library, but normally you just leave it as it is unless you have a strange LED strip that then you need to change the timings and stuff. As you can see on the camera, my LED strip is just connected to ground, 5 volts, and the pin number 6 on the Arduino. I hope you can see it. If not, just believe me. So it's very simple, 3 pins. That's the only pin that's gonna send data. These LEDs, I don't know if you know how they work, but they are very simple. Each LED has a small chip that knows how to do networking, a different networking than the one we just did with the SOC, with the sockets and the UDP. But through the pin number 6, Arduino is going to send some information to all of the LEDs, and only the LED that has the proper address will receive that information and change the color. Okay? So you send colors to addresses. And the addresses of the LEDs comes from 0 to 20 because we have 20 LEDs, okay? To do that, we use this instruction called set pixel color. So the object pixels has a method called set pixel color, and we just put as parameter the number or the address of the LED. In this case, I'm doing this inside a for loop. So this value I is going to change from 0 to 20, going from the first LED to the last LED, and defining the color of that LED. The colors come in red, green, blue values, okay? So to explain this a little bit more, I have a serial port. I hope all of you know a little bit about this, no? You already did some programming on Arduino, right? Yeah. So I start the serial port at a certain speed. And now inside my main loop, what I do every time is I check if there is data on the serial port. I just gather that data with the instruction pairs int. I get an integer and store it in a variable called value. Okay, this variable is declared on top, so it's a global variable. And then I do this in this line. What I do is cleaning the serial port, because sometimes when you hit enter or wherever, there is more information on the serial port, and the parseInt tries to parse it the next time you start the loop, and it gets letters, so it pops out a 0. Because if it fails recognizing a number, it will pops out a 0. So that will interrupt your lighting of the LEDs with zeros, turning off all the LEDs or turning on only the first one if you don't clean this properly, okay? So this instruction will read the serial port until there's nothing available again. So the next time we read it, we just find the number at the beginning of the data, okay? Now this for loop is going to colorize my LEDs. What it does is it goes from the LED 0 to the last LED, in this case 20, one by one, okay? And it checks. If we're talking about the LED that we receive from the serial port, if we receive, for example, a 5 in the serial port, it's stored here, then when I is equals 5, then we're going to execute this instruction, right? So this first instruction is the instruction that's going to be depending on the serial port input. So that LED is going to turn green, red 0, green top or 250, and blue 0. Then the LEDs that are on the sides of that one, so if the difference between that value and the value we are checking is only 1, that means the LEDs that are one LED far away from the central one, I'm going to light them, but slowly, not full color, but just a little bit of green. That's just to create a fade effect. That looks pretty nice when you move your LEDs fast, right? And the LEDs that are 2 LEDs far away from the central one just have a little touch, the minimal touch of green that I can give to them. So they are almost off, but they have a little bit of green. And the rest of the LEDs that are not the one that I'm asking, neither the 2 on the side, neither the 2 on the extra, are off, 0, 0, 0. Okay? So in this loop, I colorize all the LEDs, and then I tell the strip, show my modifications. And I do a small delay and again check. If there's something in the serial port, then I do it again. If there's nothing on the serial port, then the data I'm applying to the LEDs is exactly the same that I had before. So every time I receive some data from the serial port, I'm going to update my LEDs. Let's try it from the console before going to Blender. So I open a console. You see it? I hope you do.
We do.
We do.
You do. Okay. So I'm just going to check where is my Arduino. My Arduino is connected to TTI USB 0. Depending on your system, this name can differ or depending on what you have connected to your USB port. And Windows normally is COM1, COM2, COM3. It's the same that you found here on the tools. Oh, in fact, I can check it here if you like. You can check it here if you like. You don't need to do strange stuff. Now, if I open this, I'm connected to my LED strip. So I'm going to try to show you the LED strip on the camera and see that it's working. So if I send a 5, then it moved, right? I send a 10, then it goes to 10, right? You don't see what I'm typing because this console doesn't have echo. So let me do it on the Arduino console. Here, you see the number there, no? I don't see it because Zoom blocks it, but if I send a 0, then the LED goes to the bottom. I don't know if you see the bottom, yeah. So now it's pretty slow and it's not funny. 5 goes up, 9 goes top, etc. Okay? Now, one small trick, because when you do this, you're gonna say, oh, this is not reactive, this is very slow. I send the number and it takes a lot of time to do it. That's because he's waiting for longer numbers, because this instruction parse int will try to parse the amount of numbers you type. So unless you send another character after the number that's not a number, he will wait until the timeout expires. That can be almost a second. Okay, so if you want it to work really fast, you type the number, then a space, for example, and then you send it. So it will do it immediately. Okay, that's why in my Python code, I send a number, a space, a number, a space. So it reacts really fast. Now I'm going to go, it's working. So the Arduino side, it's okay, right? LEDs and a code that receives a value from 0 to 20 and changes the LEDs, which LED is on. So let's go back to Blender. In Blender, I already modeled this. I already limit the movement of my arrow. So what I want to do is to grab the position in x-axis of my arrow and convert it to a number from 0 if it is close to the first LED to 20 if it is closest to the last LED, right? That's my first task. So I load a template also, but now I did it a template of model operator, okay? I think the error that Benji catch in the previous one was because of this, because I was jumping between model and timer. Right now we want a model operator because we want the event to trigger. We want that the event that triggers of sending the data sending is the movement of the object, not a timer, right? We just want to send data when the arrow moves. We don't want to keep sending data every now and then, because we just get the serial port stuck with data without meaning. We just want to send data when there's a change. Okay, so what do I added here? I added import serial. Let's do it from the terminal here on, let me open a console, a Blender console, so you can see it, a Python console. I'm going to go copying the same as we did before. No, import serial. You can import serial here, and there's no problem. This is instead of importing socket, right? Before, the tool we were using to communicate was a socket, and now we're using a serial port, right? So what did I did here? I changed the name. Now it's LED strip control. Later, remind me to show you why I did this, because I didn't show you in the last example. Then this code was there. It's just to get the position of the mouse and be able to change the position of the arrow based on the X of the mouse. As you can see, it stores the position of the mouse X value here in this variable. Now, these three, I did add them. I have a value called LED and a value called previous LED or prev LED. This is for storing the value that I want to send to the strip, which LED I want to turn on. And this is for storing which LED was on the previous time, because in that way I can check if it changed or not. And this is the creation of the serial port. Okay, I'm going to copy and paste this. And I have an error here. Device or resource busy. That means that I'm using the serial port here. And once I free that port, I should be able to access it. Let's try again. Okay, so you cannot share serial ports between applications, okay? Applications complain about someone else using this port, I cannot use it. So remember to close other applications that are using that. Now, SEER is my serial port now. If I do write to that a value, like I'm doing it here. Now, here I send a variable, but I think I can do it like this. For example, I want to turn on the LED number 10. So I send a 10 and a space, and it moved, right? If I change to 15, it moves, right? So it works from Python also. I just create my serial port and send a number, and the Arduino is receiving that 10 and a space to change immediately, right? So I want to do that, but based on Blender movement. This part is already explained. Now here, I did some lines that maybe you can study later. I'm just going to mention briefly what they do. I get the location of the object that is selected and assign the value of the mouse plus the first value of the mouse plus the delta. That means how much the mouse has moved. And this last variable is to multiply the delta. This line comes with the template, but I modify it a little bit so it's a little bit more responsive. If I move my mouse small movements, the arrow will move a lot because I change this variable from 0.01 to 1. Okay, now these two, what they do is if the location of my object is smaller than -50, if for some reason the arrow managed to go to a smaller position, I want to correct that position and I keep it there. Okay, that's the Python way to limit the movement as we are doing here. So I'm doing this just to be sure that the variable I receive is not greater than 50 or smaller than -50. Then in the variable LED that I created up here, I store the location of my object plus 50. That's because it comes from -50. So I want it to go from 0 to 100. So if I add 50, the minimum point will be 0 and the maximum will be 50 plus 50, 100. So I have a value between 0 and 100. I multiply that by 2 because in fact I have 20 LEDs and it's easier for my brain to divide 200 in 10 pieces. So I have a value, I have only 20 possible values, okay? Dividing that 10 times. So if I print here the LED, I do it here, I will see a value between 0 and 20 and an integer value, not 0.5 whatever, because I convert this value to an int here. So I will see a rounded value. I will jump between 0 and 1 and 2 and 3 and 4, etc. I won't see 0.5, 1.8, etc. Okay, so that's what my Arduino is expecting, a number between 0 and 20. Here, what I do is, if the new value is different from the previous value, then send it. If not, just continue. That's just to update the changes, not to send values all the time. What I want to send is the value of the LED and a space. So I join them in one variable to be able to encode that value in the proper encoding of text that Python accepts. okay? Then I print that to the console, so we see the changes on the console, and I store that value. Well, here I send it to the serial port, serial write, and I store that value in the previous LED, so I can check later if it changes again. You're going to study that with calm later. Let's try it. If I click run script and I move, you can see that it updates almost instantly, right? And on the bottom of my screen, you can see the number, how it does change. 0, 1, 2, 3, 4, etc. until 20, right? Pretty easy. And if you see on my Python code, to cancel it, I have to click right mouse button or ESC. And to finish it properly, left mouse button, okay? In my case, it applies, any of those three options apply the same. Now, I can run this as if it were a tool in Blender. If I just click F3, hit F3 and search for the name of my script, the name of my script is LED strip control. That's the name I assign to my operator. And I search in Blender for an operator that controls LEDs. Then I found my tool. Okay, my tool is already registered inside Blender. I can add it to menus. I can do whatever I like with it. So I can click this and start controlling my LEDs. Okay, I can add that to my shortcut menu. So I can write my scripts and control stuff as if it were part of Blender. That's why it's important to put a proper label, so you can later just use it without having to find for model operator in Blender. Just LED strip control. Okay? Questions? No? Did I manage to make you sleep or not?
No, it was good.
No? It was interesting?
But continue.
Yes.
I have there's a lot of other ideas that are pretty easy to implement with this that I didn't have the time to do it. But for example, controlling a servo motor, modeling some robot on Blender, and then moving that robot will replicate the movement in a servo really easily. If you know how to control something with Arduino, you just grab the data from the serial port and use that data to control it. Okay? Keep in mind that this model can be mixed. Networks are a different layer from the data that you're sending. So you can send that data through Wi-Fi, through a cable, via serial port, or use MQTT. That's a protocol to send data. I think you remember it from the MDF course that we did. We use MQTT. I don't know if Fab Academy already did something.
Not yet.
Not yet, but you will know what it is. What I'm saying is, you can talk any kind of languages and devices can talk between them if you select the proper protocols and you have well done the endpoints of the different parts. It's just the same as the internet. You can control my LED strip from your home with a Python script without problems. If you know my IP and I open the port on my router, you can access directly and send numbers to it, right?
Nothing. I was thinking we could make it the same height as the other block, but it is, I think.
Oscar.
The same height as.
Oscar, turn off your microphone. Okay. So
I have a question.
Please.
So, but we need to have a public domain to access, like I have to have a public domain to access to other network from my system?
No. There's a lot of techniques and you will find a lot of tutorials on the network. What you need to know is your public IP. Okay, on the internet, there are a limited number of IP addresses because the combinations of numbers is limited. So you have a public IP that your internet service provider, your ESP, Vodafone, whoever it is, Orange, give you. But the problem is they give you one that changes on time. So when your modem, your router at home connects to the internet, it will get one, an IP. And that will change, maybe the next day will be different. Okay, so the problem is that to locate your home, you have to know that number. Okay, and you can do that if you want to go for the cheap and free side as me. You can do that with a dynamic DNS. There are services on the network that you can register for free and ask them to update a name that they will give you. For example, I have my computer connected to bico.ddns.net, and I run a small script on my computer on Linux that updates the IP. So every time I connect to the internet, my IP address changes, but I know it, and I send an update to that dynamic DNS service. In that way, every time that I go to bico.ddns, etc., I can access it. So you need a domain with a dynamic IP address, okay? You don't need to buy a domain because there's a lot of services that will provide you a temporary domain, okay? If you want to go to the complex side of that, but learn a lot, you can set up a Raspberry Pi with your own DNS server that spreads your changes on the internet. And then you can just buy a simple domain and run your own DNS server in a way that you have your domain at home and it is updated as Google is updated, okay? So every time you access your domain, you will be accessing your own Raspberry Pi. There is some other options. For example, there is, well, you can set up a VPN network, so you can connect to your home like you were in a local network. That's a little bit more complex. You can go to, maybe you know Dataplicity service. That's a service where you can have a Raspberry Pi connected to your local network, and you just run a script on your Pi that will give you access from the outside. So you go to Dataplicity, you register with a mail, it's free for one Raspberry Pi, and you can access that Pi from whatever place in the world, because your Pi, every time the Pi boots, it will send his location to the Dataplicity server and tell them, I'm here in this IP, and create a tunnel, an encrypted tunnel between their servers and your Raspberry Pi. So if you access Dataplicity, you can talk to your Pi, okay? And there's a lot of other options to do that. So no, you don't need to spend any money. You don't need to buy anything. You can do it for free. You have to learn a little bit how networks work, but it's possible. So it will be a nice exercise between students, being able to control your devices between yourself. Even if you're at home isolated, you can create your own servo that will scratch the neck of your friend on the other side of the screen, no? Every time you move your mouse.
The best week in, I don't know about the other guys, but I think that week we did that stuff was, I think my favorite week.
Yeah, did you enjoy it?
Yeah, I agree. Oh no, also the useless machines were amazing.
Yeah,
so.
those 2 weeks were the best.
So I think,
guys,
yeah.
Just it's not to content you, but also this week we started networking. On Friday we will do something like what you're saying, Victor, with Node-RED. So we will do like networks. We will learn a little bit about this on Thursday, and then do like maybe dashboarding, and we will see if we can control things from one another. But it's on plan. So the idea here is that you try to break frontiers and open your mind in terms of everything is transparent. You can jump from one Arduino to a Wi-Fi network to a serial port and send to the internet the data and control it with your phone and via Telegram message and your voice, irrigate your plants on your balcony. And that's the point. If you learn these small tools one by one properly, then you can link them to do whatever fancy stuff you like. My idea is to try to give you another tool on this set of tools to connect things. So you can model things on Blender, you can build 3D environments and link them with whichever thing you want to do. Okay, you can control a real robot on the Fab Lab from home if you have the robot inside Blender and the 3D model of the lab, and then you can move it inside and it will replicate it outside, etc. Okay, and it's not so complex.
And
so,
is there a way to export the experiment out of Blender? So let's say you just you just have to say, like, you have a robot that you can control inside Blender to make it move outside of it. Is there a way to export that application outside of Blender so you can give it to the public and not the
You mean like a bit like Unity Engine or something?
Yeah, kind of.
Like making a video game, let's say, to control your robot, no? Kind of, or an interface with a 3D models.
Yeah.
It was a lot easier before because Blender had a game engine integrated. Okay, they decided to remove it because it was pretty old code, and now there are game engines that are a lot better outside Blender. So they are pushing the model of you exporting this and linking it outside in an outside game engine. I am not pretty experienced with gaming outside Blender. As far as I know, Godot is one of the best open source game engines, and it's pretty well linked with Blender. So I'm sure you can do that. I don't know where to point you to do it, but if you read a little bit about Godot and Blender, I'm sure that if you can manage to do it from inside Blender, you can export an executable from Godot with the rules defined there and create kind of a video game that allows you to do that without opening Blender, no? Just opening an external application. Okay.
Okay, thanks.
Also keep in mind that Blender is just one option, but you can do this with JavaScript in a web page. You can do this with Python code on the console, or whichever software you like. No? The idea to show you this in Blender is just to break frontiers. No? You can do that even inside a 3D application. Okay. So if you have any other question, if not, I think that's all of it from my side. I hope it was entertaining and divertido, fun.
Yeah, it was good.
Yeah.
Thank you.
Yes, thank you. Thank you.
Yeah, it's nice.
You're welcome. So please, if you do some stuff, post it in some place and share it. So it will be nice to see. As Santi was saying at the beginning of the class, we can maybe build a page with all these examples and exercises because it is fun to do.
We're using in MDEF the Mighty Networks, and I think it's pretty cool to share stuff. So maybe we can use that too.
Yeah.
Or set up the Fab Academy Mighty Network, no?
Yeah, exactly. That's what I'm talking about. Like, create an experimental, I don't know, Fab Academy
space
network.
Yeah, I think Oscar and Santi are better than me to discuss that with you and the media and the ways of collecting that, because I'm not into Fab Academy organization. But of course, any way you find to do it properly, it will be nice. And if you share it with me, I will be happy to see what you did. Okay, so I hope to see you soon. Really see you, not through a screen.
Hear you.
And do real classes, because this is not okay.
No, it's also okay because we can go back to it. So the recordings are nice.
Yeah, but real people is nicer than recordings.
That's true.
We can record real people as well.
Yeah, obviously.
Yeah. In 3D.
I don't know anymore. I'm fine with virtual.
Okay. You can see it from home if you like, but I will to do classes on a real space. Well, so if there's nothing else, Oscar, I say goodbye.
I just have an offshoot question, but it's about the Code Club. What's gonna happen today?
Yeah, we're gonna do a follow-up question on a follow-up session on computer vision. So we did 2 weeks or 3 weeks ago, I don't know, with Easter break. We started computer vision and starting to identify objects in it. And today we are gonna finish that and go a little bit deeper. Yeah, and that's it. If you want to come, of course, feel free to join. It's from 4 to 6.
Thanks.
and of course it will be recorded as well. If you have time as well and you want, you can also watch the previous session before joining. Probably it's too much, but I recommend it so that you're not lost.
Thanks.
When you finish computer vision and you manage to recognize pigeons, I have one assignment pending in my balcony to build a robot that scares pigeons when they are recognized by a Raspberry Pi. So if someone does it, I will be very thankful.
Victor, we do that in Greece with all CDs.
Sorry?
In Greece, we do that with all CDs. You have,
yeah, my neighbor does that, and I don't know if you have seen some brightness coming up and down in my face that I have to do that. It's because my neighbor believes the same method that you use. He has CDs hanging there, and the sun is like, yeah, it doesn't scare me.
We have
to find a method.
It also
we have a real life thing that's called my dad.
It could be the
we have to find a method with ultrasound. I think that probably they have hearing capabilities or something better than us, and maybe we can scare them with ultrasound. And also the dogs industry.
Maybe it's going to attract them rather than just have laser pigeons. Cool. Okay. See you later.
Bye-bye.
Thank you.
Bye. Thanks. Bye-bye.
Thanks. Bye-bye.
No te vayas todavía. ¿Quién está grabando?
No lo sé. Me imagino que Santi. Pero ya no está Santi, entonces será Josep.
Josep, ¿estás?
No. Parece que no.
Ok, bueno.
Dime.
Pues no sé. Vale, no, te iba a decir por esto de lo que hablamos.
Pero
estuve hablando aquí con...
Pero lo que pasa es que todo lo que digamos ahora queda grabado, esa es la cuestión, ¿verdad? Entonces no quiero...
Por eso, sí. Ya, luego ya te... Espera,
bueno, podemos hablar ahora si quieres. Nos conectamos a Jitsi si quieres y me comentas.
Voy a avisar solo para que no vaya a ser que se pierda, es que no sé cómo... Si quieres salirte tú o algo, yo me quedo para que se quede la sesión.
Vale, ahora hablamos.
Venga. Vale. Recording stops.